So in this podcast, you're going to be introduced to the way chemists talk about concentration. And concentration is simply how many solute particles you have in a certain amount of solution. So if there's a lot of them, we say it's concentrated. And if there's not many, we say it might be dilute. So concentrated and dilute are opposites of each other. Often if it's a colored solution, the darker color it is, the more solute particles you have. So you might say that's concentrated. And if something is like a very dark green and a light green, we know they both have the same compound in them. The lighter one is dilute, while the more concentrated is, or the darker is more concentrated. So again, we're talking about molarity. And this is how chemists or scientists talk about concentration. And molarity simply has the units moles per unit volume. Okay, so it's always how many moles of solute. All right, so we're going to go ahead and add this: moles of solute over liters of solution. Okay, so how much solution, how much space does our entire solution take up, and how many actual moles have we dissolved in that solution. Okay, so what we're going to look at is really 4 math problems. Okay, we have an equation. We can solve for 3 different things. We can either solve for molarity, or we can solve for moles, or we can solve for liters. Alright, so our first question says, if you dissolve 12 grams of sodium chloride in 150 milliliters of water, what is the molarity? Okay, so in this particular question, we are solving for molarity. So I'm just going to write my equation, and I'm going to put molarity, that's x. I have x equals, and I can figure out my moles, and I can also figure out my liters. Okay, but we're really solving for molarity. So liters is simply, if we know milliliters, if we divide by 1,000, we get liters back. So up here, if I divide by 1,000, I'm simply going to move my decimal 3 times. So liters is really the same as 0.15 liters is the same as 150 milliliters. And then to go from grams to moles, this is what we learned our first unit. If I have 12 grams of NaCl, I'm going to set up a fence and rail problem. So if grams of NaCl is on top, I have to have grams of NaCl on bottom, and I want to go to moles. Well, if you remember from our first unit, what number always goes in front of moles? It's going to be 1. And 1 mole of specifically NaCl, what is that weigh? Well, I'm going to look on the periodic table, and I'm going to find out it weighs 58.443 grams. When I do this calculation, I get 0.21 moles of NaCl. Alright, so I'm now going to put that into this equation that I have written over here. Okay, so I'm going to use this equation now. I'm going to solve it over here on the left, or on the right. So I really have 0.21 moles divided by 0.15 liters. When I do this, I get 1.4, and then our unit for molarity is simply a capital M. Alright, and we would say this is 1.4 molar, just like you have molars in the back of your mouth. Symbol is capital M, but we pronounce it molar. Okay, so our solution is 1.5 molar. The higher that number is, the more concentrated it is. Alright, because we have solute on top, so if we have more stuff, the higher the number, the more concentrated, the smaller the number, the less concentrated. Alright, so our next problem is saying, how many grams of NaOH would be needed to make 500 milliliters of a 1.5 molar solution? So in this case, again, we know molarity, because we know capital M, and we also know volume again. It's given in milliliters, but I can easily change milliliters to liters. So my x must be my moles, okay? But what does my question ask for? It asks for grams. So it doesn't ask for moles, but I can always get grams from moles. So on this problem, we're going to go ahead and put kind of some numbers that we know so far. And we know 1.5 molar, and that equals x over, well, again, if I divide 500 by 1,000, I get 0.5 liters. So I'm going to change this to 0.5 in the denominator liters. So when I solve for x, I find that x equals, if I take half times 1 1/2, I'm going to get 0.75. Alright, and what's my unit going to be? It's going to be moles. So again, the problem asked me for grams. So really this just becomes the first part of my fence and rail problem. I'm going to put 0.75 moles of NaOH. Do my fence and rail, have moles on top, so who's on bottom? Must have moles on bottom. And I'm going to go to grams. What number always goes in front of moles? 1 does. If we look in the periodic table and add a sodium plus an oxygen plus a hydrogen, we get 39.997 grams. And if I do that math, I get 30 grams of sodium hydroxide. Alright, our next problem, if you notice, says what volume would need to be used to make 2 molar solution from 25 grams of magnesium chloride. So in this problem, I know molarity, and I can really get moles, because I know grams, so I can always get moles, and now I'm solving for volume. Alright? So because we're starting with grams, the first thing we need to do is convert grams into moles. So I'm going to start with 25 grams of magnesium chloride, which is MgCl2. I'm going to set up my fence and rail. I have grams on top, so I have to put grams on bottom. And if I have grams on bottom, I can go to moles. And my number's going to always go in front of moles, 1. If I add up an Mg plus a Cl plus another Cl, really a total of 2 Cls plus an Mg, I get 95.211 grams. When I do this math, I find that I have really 0.2626 moles of magnesium chloride. Okay? So I'm going to plug it back to my original equation. I know my molarity. My molarity is 2.0 molar. That equals 0.2626 moles over X. Okay? So when I, probably the easiest thing to do is cross multiply. So I can have 2x equals 0.2626. So I'm going to divide both sides by 2. And when I solve this problem, I find that my answer is 0.131 liters. Okay? So again, we can solve for molarity, we can solve for moles, we can solve for volume. Alright, so from that, the question really that needs to be raised is, how can I make these solutions? Okay? What if I have to make up a certain specific solution that has a specific molarity? Okay? So if we are talking about diluting, typically we order chemicals that are pretty dangerous and they're in the back room, students don't ever see them, but it's cheaper for us to order something really concentrated and then dilute it to the solution that we want to have for a specific lab. Alright? So we're going to talk about dilution really quickly. And dilution is simply taking something that's really concentrated and adding water to it, alright, and really kind of watering it down. But the scientific way of saying that is we dilute it. So our dilution equation is simply this. M1V1 equals M2V2. Alright? This kind of looks familiar, alright? With our gas laws, we talked about P1V1 equals P2V2. That was known as Boyle's law. You don't need to remember that, but that was the law. So this one is molarity initially, or to begin with, times volume to begin with, equals molarity to end with, times volume to end with. And if you remember from this, it's an inverse relationship. Okay? So, I'm just going to put inverse relationship. So if my volume gets bigger, what's happening to my molarity? It's getting smaller. If my molarity is getting larger, what's happening to my volume? It's getting smaller. So if we look at this last example, or last question, we see it says, what volume of 3.5 molar sodium hydroxide would be needed to make 50 milliliters of a 1.4 molar solution? Okay? So with that, we're just going to kind of look at this. And we know these two values to begin with. We know a volume and a concentration. So we're going to use those as our initials. okay? Or our M1V1. So our M1 is 1.4 molar. And here, just like with our gas laws, whatever units we begin with is going to be the units we end with. So I can just leave this 50 milliliters. I'm going to set that equal to my new concentration, which is 3.5 molar. And notice the question asks, what volume would be needed? So really my V2 is my X. Alright? So how do we solve for X? We're going to divide both sides by 3.5 molar. And notice my units for molarity are going to cancel out. So I have molars in the denominator, I also have molars in the numerator. So molars go bye-bye. So I'm really in my calculator going to put 1.4 times 50 divided by 3.5. When I solve that, for X, I get a value of 20 milliliters. Alright, so what does this mean? It says what volume of 3.5 molar would be needed to make 50 milliliters of 1.4 molar solution? So what I'm going to do is I'm going to take the concentrated stuff and pour 20 milliliters of that into a beaker. Alright, so I'm going to take 20 milliliters and put it in the beaker. But what do I want my solution to be? I eventually want 50 milliliters. So to that 20 milliliters of concentrated stuff, I'm going to now add 30 milliliters of water. How come? Because I want a total solution of 50 milliliters. And when I add the water, it goes from 3.5 molar to 1.4 molar.